Hello everyone, welcome to my class. As we know that one branch of mathematics is called statistics, and one chapter which connect both these fields is probability. As much in mathematics we use probability, as much we use probability in statistics as well, because we wanted to predict about how close our samples are to our population. Just because to know this answer, we have to study the whole concept of probability in statistics. So, in our today's class, in the world of statistics, we will study about two probability distribution. In order to know about probability distribution, you can refer to my previous video. So let's start learning about two type of distributions which are very famous, binomial and Poisson. So, in order to make this lesson very interesting, we will take only one example of both binomial and Poisson distribution in order to understand them in an easy way. So, before we start learning what is binomial distribution or Poisson distribution, let's take an example of an experiment. Our experiment we are going to conduct is that we will toss a coin. So, as you know, the number of time you will toss a coin is called a trial. So there are few words you must know before we proceed further. One is the trial. Trial is number of time you will toss the coin. So let's toss a coin two times. It means we will do two trials. So just think that if I toss a coin two times, these things can come. Either you will see head and head, either you will see tail and tail, either you will see head and then tail, or either you will see tail and then head. Can you imagine any other possibility other than that? No, there cannot be any other possibility than these four things. These are called possible outcomes, and we also call them sample space. These things like head head, tail tail, they are possible outcomes and also called sample element. So what we learn is that if you toss a coin two times, you can only see four possible outcomes. Nothing more can come. Now, the question is that why we are tossing the coin two times and what do we really want it to know? Actually, what we wanted to know by tossing a coin is called an event. So my question is that what are the chances of getting a head if I toss a coin two times? As we know, there are four possibilities. In possibility, if I see a possibility head and head, if I toss a coin two times, in the first in the first trial I see a head, in the second trial I see a head. So how many times I can see a head? I can see a head two times. In possibility tail and tail, I can see head zero times. I will never see head. In possibility third and fourth, it means head tail and tail head. You can only see head one time. The answer in which I am in search of is that what are the chances of getting head? In order to know this answer, I have to create all the possibilities. So I have how many possibilities? I have three possibilities: A, B, and C. So actually, in order to know this answer, we have to find probability of head in each possibility. Yes, in possibility A, we also have to find the probability of head. In possibility B, we also have to find out the probability of head. And same applies to possibility C as well. So let's see. As we know that we cannot make a probability distribution without giving a possible outcome a random variable. As we have possibility A, in A possibility, we were having how many possible outcomes? Only one, head and head. And how many times we can see head in it? Two times. So we will make our random variable what? That random variable will be number of head we can see in each possible outcome. So possible outcome A has random variable 2. In the same way, possible outcome B has random variable 0, because in B possible outcome we were not having any head. In possible outcome C, we were having only one head, so we will give it a random variable 1. So what we learn is that our objective is to find the chances of head in each possible outcome. So we have three possible outcomes and we will try to find out chances of head in all three possible outcomes. So before we learn about what is binomial distribution and what is Poisson distribution, we must see how to solve it first. So our first situation in which we wanted to know about chances of head is called chances of random variable 2, means chances of seeing head two times, or you can also say probability of getting two head. Here is our amazing formula of binomial distribution first that I'm going to show you, and it is called this. There's no need to go deeper, there's no need to learn what this thing is, there's no need to get confused because I will show you how to do that. And I will also teach you what is binomial distribution. But before that, you must understand that we can solve a binomial distribution by this formula. It means we can know the chances of or probability of getting two head in two trial, or chances of getting random variable 2, or chances of seeing two head two time a head two times, okay, in by help of this formula. In the same way, now it is the time I will show you how to do that. On my left side I have shown you how to solve it. On my right side I will show you what is the meaning of various terms used in this formula. As you can see, the first term we have is px. P stands for finding out the probability and x is our random variable. The first random variable we wanted to know is 2. It means what are the chances that in our four possible outcomes we will see head two times. So x will be 2 and px stands for probability of random variable 2. Now n factorial. Before we learn about n factorial, we must know that what is n. N is the number of trial we are doing. As we know that we toss a coin only two times, so number of trial will be 2. As we studied in our younger classes, or when we were in class 9th and 10th, is that factorial stands for uh, into 1, 2 into 1, 3 factorial stands for 3 into 2 into 1, 5 factorial stands for 5 into 4 into 3 into 2 into 1, 6 factorial stands for 6 into 5 into 4 into 3 into 2 into 1. So these are the terms called factorial. Now what do you mean by the next P? P stands for probability of getting head in a single toss. The probability of getting a head in a single toss is always 1 by 2. It means 0.5. It will always be same, always be same. In the same way, probability of getting tail in a single toss is always same. It is zero point 0.5. So now because we know all the terms on our right side, we can start solving the question. So px is equal to 2 factorial. So 2 factorial is 2 into 1 divided by n stands for 2 trials, 2 minus 2. Here 2 stands for random variable. Now 2 minus 2 is 0. So 0 factorial minus 2 factorial. So into probability of getting head in a single toss is 0.5. So 0.5 square into 0.5 into probability of getting tail in a single toss is zero point 0.5 as well. And we will power it with n minus x. Here n stands for 2 and minus 2. 2 stands for random variable. So here if you keep solving it, you will reach to an answer called 0.25. In solving this formula, we have to keep in mind two things. One is that while solving this formula, if you ever see zero point 0.5 power 0, it is always considered 1. Another thing we have to keep in mind is that 0 factorial, maybe you are thinking it's 0 into 1 is 0, but 0 factorial is always 1. So there are two things we have to keep in mind when you start solving this formula. So once we solve it, what we observe is that the possibility that in 4 possible outcomes you will see 2 heads is only 0.25. So I request you to solve the probability of random variable 0. It means you will never see a head in 4 possible outcomes. Yes, we will use the same formula. We just have to put our values in these formulas and we can solve it. In the same way, probability of getting one head is can be solved with the same formula. So with the help of this thing, we can solve 3 possible outcomes in which we can see head. It means chances of getting head can be seen in 3 possible outcomes A, B and C. And this is how we can solve, or this is how we can know the probability of getting head by help of binomial distribution formula. Now, before we start learning what is a binomial distribution, I already told you that in the end I will discuss with you what is binomial distribution. So what did we learn from this particular previous pictures? We learned and we saw a binomial distribution in our previous example. We saw what? We saw that we toss a coin 2 times, but in each trial head can come or tail can come, but both have same probability. It means 0.5 and 0.5. As we saw in our example, P was 0.5 and Q was 0.5. Remember, we saw that we have a head and we have a tail. It means you can make a binomial distributions only when in each trial only 2 outcomes can come. You cannot do a binomial distribution if outcomes are more than 2. In our case, our event was to know about head. So in binomial distribution, the event which we wanted to know is called a success. And the event that we don't wanted to know or opposite is called the failure. So if head will come, then head will also not come as well, or tail will come. So it is called a failure. So we saw the same thing in our previous example. So we have to learn first thing about binomial distribution is that only 2 outcomes can come and only 2 situations will be there. Either you will get success or either you will get failure. Yes, only 2 outcomes, head or tail. Now many people will ask me that if head will come or tail will come, can we also do it in the case of a die as well because there are 6 outcomes? Yes, you can do that, but you have to make your event like this. That what is the chances of getting a 6? What are the chances of not getting a 6? In this case, you can make a binomial distribution because chances of getting a 6 is called success and chances of not getting a 6 becomes a failure. So there are very few conditions, but it is very popular in this head and tail situation, and only when there are two outcomes. Now, one more thing we saw in our previous example, that we were having a fixed number of trials. Yes, in case of yes, we have fixed number of trials. I can make a binomial distribution only when I have fixed number of trials. It means if I toss a coin two times or three times, I have four times, I have to specify this thing how many times I'm tossing the coin. Now what I saw is that trials are independent. Now what do you mean by trials are independent? Trials are independent means that if I toss the coin for the first time, the chances of getting ahead was zero point 0.5 and zero point 0.5, right? But if I toss the coin again, the chances of head and tail will remain the same, zero point 0.5 and 0.5. It means trials are independent. One trial doesn't affect the probability of the second trial. So remember, what we saw in our previous example have all these following conditions, and these are very crucial if you want to solve a binomial distribution, if you want to make a binomial distribution. Now let's see about a Poisson distribution. Poisson distribution, if we apply the same situation in Poisson distribution, yes, we can solve or we can find the probability of getting ahead with the help of Poisson distribution as well. Let's see how to do it. As we all know from our previous example, we were having a condition situation in which we wanted to first know the probability of getting two heads. But now one thing has changed is the formula. The formula of Poisson distribution finds probability in a different way. The formula is like this. Now there is no need to go deeper in these terms because I will explain you how these terms work. Let's see a example. On the right side we have the terms, and on the left side we have the solution. Let's go on the right side and read the first term, that is probability. Yes, we are trying to find out probability. But the next term we have is x. X stands for random variable. In our situation, we have a random variable 2. It means we wanted to find out probability that how many times in 4 possible outcomes I can see head 2 times. Now the third term makes this formula very special is lambda, or you can say lambda. It is called the average number of occurrence in a given trial. For example, if I toss a coin for one time, head can come zero point 0.5 and tail can come 0 0.5. And how many times I am tossing the coin? I am tossing the coin 2 times. So the average number of occurrence of both outcomes is 2 into 0 0.5. So that is what called lambda. We will know it better with the help of our example as well, with our solution as well. The next term that makes this formula very special is Euler's number. A Euler's number is a number that you always have to keep constant. It means it is a number that is always constant. It is 2.718. You cannot change this number. It will remain constant. Now let's solve it on the left side. Probability of random variable x is equal to lambda power x into Euler's number power lambda, which is in minus, divided by random variable factorial. So let's solve it. Probability of random variable x is equal to lambda. Lambda is average number of occurrence in a given trial. So we have two trials. 2 into the possibility of coming of head is 0.5 and possibility of coming of tail is also 0.5. So the average number of occurrence you can see in two trials is 2 into 0.5, and we will power it with random variable which is 2. So we will get 1 power 2, and 1 power 2 is 1 into 2.718 minus 1, because our lambda is 1. So 2.718 minus 1. When you have a power of minus 1, you write it like this: 1 divided by 2.718. In our denominator, we have 2 factorial, which we will solve it like this: 2 into 1. So finally we have 1 into 0.368 divided by 2, and that is how we get 0.1839. So here the probability of getting 2 head in 4 possible outcomes is 0.1839. But in our previous case in binomial distribution, the probability of getting head 2 times was 0.25. Quite different, right? Very different. Yes, both are different. But before we know why they are different, let's solve our another random variable, which was 0. The chances of getting 0 head in 4 possible outcomes can also be solved with this same formula. The chances of getting a 1 head can also be solved by this formula. Now let's try to know that why these both formula were giving a different answer. So we have to wait. They are very different. So we can read very carefully that both can find probability for tossing a coin 2 times. Yes, both can find and getting a head. But who gave the right result? It depends upon a very big factor that is called how many outcomes are possible. In tossing a coin 2 times, there are only 4 possible outcomes. So never prefer a Poisson distribution, because the results it is giving are not preferred by mathematicians, because the possible outcomes are only 4. But we can still find it, because it is possible to find it, but the results are not preferred. Second is the chance of getting head above over 0.5, right? But Poisson distribution require that probability of getting a head should be less than 0.5. It means chances of getting the event to happen should always be less in Poisson distribution. It means we learned 2 conditions for probability distribution in Poisson distribution. Is that number of outcomes? It means we are having head head, tail tail, and head head, right? They should be more than 4. Otherwise, Poisson distribution can give you answer, but it is not preferred by mathematicians or in statistics. In the same way, the chances of getting head were 0.5 and they were constant. But in Poisson distribution, the chances of getting an event or a head, in our case, should always be less than 0.5. Then Poisson distribution can give you better answer. So that is why, because in tossing a coin, head can come 0.5 and tail can come 0.5. They remain constant, right? So Poisson distribution in such cases is not recommended. So in tossing a coin, Poisson distribution can give you an answer, but it is not recommended that while tossing a coin you should choose Poisson distribution, because chances of coming head are always 0.5, which is not large enough to give a right result, because Poisson distribution doesn't work in this way. So do you know that Poisson distribution is not only applied in the cases of tossing a coin, which is generally not preferred by mathematicians or statisticians, but Poisson distribution can be applied to many other situations as well, for which it is more preferred. So we will discuss in our next video, when I will show you that how Poisson distribution can be applied to many other situations. So thank you so much for listening to my lecture. And today in our class, we learned about how Poisson distribution, Poisson and binomial distribution are same but quite different in the situation they are applied. So we will discuss in our next video in how many amazing cases Poisson distribution can also be applied. So thank you so much. See you in the next video.